Artificial intelligence has long been a part of our everyday lives. It is used in search engines, voice assistants, navigation systems, and creative tools for text and images. ChatGPT and other large language models advise us, recommend movies, or plan our vacations. Klaus-Robert Müller is a professor of machine learning at the Technical University of Berlin and director of the Berlin Institute for the Foundations of Learning and Data, BIFOLD. He is one of the world's leading researchers in the fields of machine learning and artificial intelligence. Originally, Klaus-Robert Müller studied theoretical physics and computer science. He realized early on that an academic career in theoretical research would be difficult.
Also, es hat mich, glaube ich, als Wissenschaftler.
I think that, as a scientist, once I'd left that purely theoretical realm behind, I was always driven by the desire to do something that would make the world around me a little better.
Besser macht mich herum.
Classical AI works with fixed rules, such as a chair has 4 legs. But in reality, chairs look very different. Modern AI, in contrast, learns from large amounts of data, such as images, and identifies patterns within them. This creates a model of what a chair typically is. But how do machines actually learn? And can we trust them? Understanding this is one of Klaus-Robert Müller's main research focuses, so-called explainable AI. Modern AI systems often deliver impressive results. However, many of them function like a black box. This is a problem, for example, when it comes to AI applications in medicine.
Wenn man aber erklärt, wie die Modelle das Problem lösen.
But when you explain how the models solve problems, there are significant differences. And we've pinpointed this in the horse class. Not surprisingly, there are horses in these horse pictures, but half of these pictures also have a copyright notice. It says Lothar Lenz, because Lothar Lenz is the photographer, and Förderfotoarchiv.de. So if you look at the models and how they solve the problems of recognizing horses, you'll see that some of them are just looking at the horse, and others are looking at the copyright tag. The example of the horse images shows how important it is to understand how artificial intelligence works, because that is the only way to use it without hesitation. Klaus-Robert Müller doesn't just want to make AI explainable. His primary goal is to bring its methods into the realm of science.
KI für die Wissenschaften ist ja so ein Buzzword, was in den letzten Jahren erst so ein bisschen gekommen ist.
AI for science is kind of a buzzword, something that's only really started to gain traction in the last few years. And I've always done this because I've always thought it's the most sustainable approach. If I develop an algorithm, someone else will come along, within 2 weeks by now, and come up with something even better. But if I bring AI into science so that we can gain new insights, whether related to diseases or quantum mechanics, then what we're doing is much more sustainable, because we're basically giving the gold miners a shovel, and with that they can keep digging for another century. Klaus-Robert Müller sees artificial intelligence as a scientific paradigm shift. For the first time, researchers have access to tools that can analyze billions of data points simultaneously, from deciphering biological processes to developing novel materials. In the field of quantum chemistry, Klaus-Robert Müller has made significant contributions using machine learning methods. What used to require complex calculations taking days or even weeks can now often be predicted in a fraction of that time. At the Hector Fellow Academy, Klaus-Robert Müller is working on a new interdisciplinary research project together with 2 members of the Academy. The goal is to develop a machine learning framework for accurately predicting the excited states of rhodopsin, a visual pigment in the retina. Collaborating with scientists from a wide variety of disciplines opens up new perspectives.
Gerade so jemand wie ich, der eher so ein bunter Hund ist, der versucht auch.
And someone like me, who's something of a jack of all trades, also tries to contribute to other disciplines with their techniques. There are countless opportunities for collaboration. If AI systems are explainable and transparent, they can also be used in sensitive fields such as medicine. Laura Cziernik is a doctoral researcher in Klaus-Robert Müller's team. In her doctoral research, funded by the Hector Fellow Academy, she uses genetic data to predict brain tumor types. Certain chemical markers on our DNA can provide important clues about diseases.
Unsere DNA ist ein langer Strang Und die
Our DNA is a long, long strand, and a single methyl group can bind to the DNA and block its reading, depending on where the methyl group is located. This binding pattern is unique to certain diseases. So methylation is always happening in every cell. It's part of a cell's natural course. But if this methylation pattern looks different from normal, then it may indicate a disease.
passiert in jeder Zelle.
The goal is to use machine learning to reduce invasive procedures on patients' skulls. To achieve this, Law Chiernik uses a combination of mathematical models to provide information about the specific type of tumor. The system is trained and validated using extensive datasets.
These AI models allow us to see connections in the data that are too complex for human thought. And I believe that if we have algorithms that can do something we humans aren't very good at, especially when dealing with large amounts of data, then medicine is actually very well suited for this, in that it ideally allows us to help people. That's actually a pretty simple motivation.
Menschen einfach helfen kann, das ist eigentlich ziemlich eine banale Motivation.
The results demonstrate the potential of data-driven research. In cancer research as well, Klaus-Robert Müller, in collaboration with physicians at Berlin's Charité in Germany, has helped develop improved treatments for patients. Müller has developed AI methods that identify patterns in high-resolution tissue images that can provide information about disease progression. This approach is known as digital histopathology. Basic research on cancer has led to clinical applications. In 2020, Müller co-founded Diagnostics, a company that now employs over 120 people and develops AI solutions for more precise cancer diagnoses.
Ich glaube, das Wichtigste an Forschung oder
I think the most important thing about research, or at least what's important to me, is that you might create a tiny little piece of the puzzle and a bit of knowledge, and someone else might use that to find another piece of the puzzle, and then, little by little, we might come to understand certain things better.
ein bisschen besser.
AI research today is extremely fast-moving. The use of artificial intelligence in the sciences, on the other hand, focuses on investigating real-world problems from a wide variety of disciplines and solving them step by step. Klaus-Robert Müller would like to see more of the latter, less hype and more sustainable scientific depth.
Und dieser Erkenntnisgewinn ist eigentlich das Wichtige.
Gaining this insight is what really matters. This applies to medicine, quantum chemistry, and many other fields. The key point is that I'm bringing AI into a new field. It becomes a tool for that field, and it will continue to be one, even 50 years from now.
Und damit bleibt es, auch noch in 50 Jahren.